Pope. Are you ready for Mass?
Right. Okay, calm down. I'll be down in a minute or so. I have to get my head around this book. Before that I have to check how many followers I have now and send a tweet. Need help with my book. I don't know what an OLS estimator is. Can anyone help? Hashtag people problems. Hopefully someone can help. What is going on?
Hello, Pope. I hear you are having problems with OLS estimators. Let's start. And less of that surprised look. Okay, Pope, so what do you know so far?
Well, I know it has to do with regressions.
Yes, the ordinary least squares estimator has to do with the classical linear regression model. Pope, what is the simple one-variable regression equation?
I think it is y equals alpha plus beta upon x.
Don't forget the error term. Alpha and beta are the regression coefficients. The alpha value can be seen as the intercept of the line, whereas beta is the slope of the line.
But where does the OLS estimator come in?
Firstly, we have to understand how the coefficients are determined. The alpha and beta chosen minimizes the vertical distance from the data points to the line. Essentially, it is a line of best fit. Pope, pay attention. Your followers can wait. We are nearly on to OLS estimators. I thought that would cheer you up. So, ordinary least squares is where the sum of the squared residuals is minimized. The OLS estimators are known as alpha hat and beta hat.
I do enjoy a good hat.
Well, OLS estimators are used to estimate the regression line of a sample. The equation is on the board.
So how do we calculate alpha hat and beta hat?
Shown on the board is the equation of beta hat. But don't look so worried, Pope. It's not as complicated as it looks. Beta hat equals the covariance between x and y, divided by the variance of x. Now we can look at alpha hat. What do you notice here, Pope?
Jesus. Is that the mean and y and x?
Yes, the equation for alpha hat equals the mean of y minus beta hat upon the mean of x.
So the regression line goes through the mean of y and x.
Exactly, Pope. You're getting the hang of it now. An example will help you to further understand. The scatter graph shows the relationship between a company's stock price and the market index. If we eyeball the data, we can find an approximate relationship. Any ideas, Pope?
Yes, I suppose you could say that there is a positive relationship.
Yes, we can see a positive relationship. If we run a regression on this data, we can find the OLS estimation of the relationship. As I mentioned earlier, we can see that the regression line goes through the mean of x and y. Alpha hat, the intercept as shown, is 40.76, and is seen as the value y would take if x is 0, beta hat is 0.1283. So this estimate means for 1 unit change in x, we expect y to change by 0.1283 units.
I think I have it. Just a few more things. How do I know it is a line of best fit?
To answer that, we need to look at the assumptions underlying the classical linear regression model. These assumptions are in relation to the random disturbance term, also known as the errors. The assumptions are detailed on the board. Can you interpret, Pope?
Yes, firstly, the mean of the error terms is equal to 0. Secondly, the variance of the error terms is constant.
And the last two. The errors are statistically independent of themselves and of the x variable. If all these assumptions hold, then we are left with blue.
Blue. I love that band.
No. Not the band. If the OLS estimators hold the assumptions, then they are the best linear unbiased estimators, or blue for short. Alpha hat and beta hat are point estimates of their true values. As sample size increases to infinity, the estimates will converge to their true values, and therefore consistent. Beta hat is a linear estimator. Unbiasedness is where the average of beta hat is equal to the true value of beta. It is efficient if no other unbiased estimator has a smaller variance. It has the minimum possible variance. Therefore the best estimator. This is known as the Gauss-Markov theorem. And we finished there with OLS estimators.
Thanks, Jesus.
No problem, Pope. Now smile for the camera.